Welcome to this video. So we've talked about arithmetic sequences and geometric sequences. Arithmetic sequences, you add some number to get to the next number. Geometric sequences, you multiply by some number to get to the next number. What we're talking about today are sequences that aren't arithmetic and aren't geometric, and they're just general. There's a bunch of different types of sequences, and we call them recursive formulas or recursion. Recursive formula is a formula that shows how to generate the next term given the previous term. So in this lesson, I think the most complicated part of the lesson is the notation. Like the actual calculations and the formulas that you use are actually pretty easy formulas. It's just getting used to what number should I plug into the formula at what time. So the recursive formula, you'll be given different formulas each time. So I start you off with actually the easy looking one. And then immediately you're intimidated because what in the world are all these subscripts? So this formula says whatever term you want to find, you take the term before it plus 2. So a sub n plus 1, a sub n plus 1 is the next term. A sub n is the term before it. So in general, just to get used to the notation, if you have some number like a sub 1, the term after it is a sub 2, a sub 3. The term before a sub 1, I guess, would be a sub 0, like that. The hardest part of the lesson is the notation when it's what about a sub n? The term after a sub n would be a sub n plus 1 is the next term. The term before a sub n would be a sub n minus 1. The term after this one would be a sub n plus 2. So I think this is the most confusing part. The actual calculations are really easy, but that's the most confusing part. So if you're confused, I'm expecting you that you'd be confused because it's confusing. So in words, sometimes it helps to think of it in words. This symbol right here represents the next term. Next term equals this symbol would be the term before it plus 2. So the next term equals the term before it plus 2 is, in words, what this means. So if a sub 0 is 9, you always have to be told where you're starting with these recursive formulas. You have to be told where you start. We're using this formula, that one right there. A sub 1 would be the term before a sub 1, which is a sub 0, plus 2. So a sub 0 is defined to be 9, so you'd have 9 plus 2. You notice the calculations are actually pretty easy. You get 9 plus 2 is 11, but it's coming up with what numbers to plug in. A sub 2 would be a sub 1 plus 2. A sub 1 we just found. A sub 1 is 11. 11 plus 2, so you get 13. A sub 3 would be the term before a sub 3, which is a sub 2 plus 2. A sub 2 we found right here is 13 plus 2 is 15. So let's look at this example. Find the first 5 terms. So I'd recommend writing it the way that I'm writing it. A lot of students like to try to abbreviate it, and then it takes them longer to figure out what's going on. So you're starting with 13. First term is 13. And you're given this function. A sub n plus 1 equals a sub n plus 5. So we would say a sub 2 equals. What term is before a sub 2? It would be a sub 1. A sub 1 plus 5. Now we're told in the directions right here, a sub 1 is 13, so it's 13 plus 5 is 18. And then I'm going to do another one, then I'll let you try one. A sub 3, you need the term before a sub 3, which is a sub 2. A sub 2 plus 5. A sub 2 isn't in the directions. Gasp, what do I do? Well, I just found a sub 2. It's right here, 18. 18 plus 5 is 23. So pause this video and see if you could try to find a sub 4. On the next one, we'd have a sub 1 is 6, so that's where you start. And this one is pretty complicated because you have this middle n right here. Students usually freak out and have no clue what to do with that. But if you write it like I wrote it over here, it makes it a lot easier to figure out what n is. So you start, you have a sub 1, so that's done, check. A sub 2. A sub 2, so you take the 1 before it, so a sub 1, plus, notice that this n is the same number as this n. Once you notice that and that registers, it makes the question a lot easier. So if this little subscript is a 1, that means this n right here is also a 1. And then plus 3 again. So you would have 6 plus 1 plus 3 is 10. Uh-oh. You didn't see that. There, 10. Let me do one more, then I'll have you try one. A sub 3 is the term before it. A sub 2 plus, now here's the money. Do you understand what the n is going to be? Whatever this subscript is, that is what your n is. So it's a 2. A sub 2, look up here. Oh no, I don't know A sub 2. Oh wait, I just found it earlier. It's 10. Plus 2 plus 3 is 15. So see if you can do the next one or the next two. So 21 and 28. The next one is slightly complicated because you have multiple variables. So notice we have a sub n plus 2 is based on two variables, a sub n plus 1 and then a sub n. So that's basically saying a sub n plus 2 is here. To find this term, you take the one before it, which is a plus n plus a sub n plus 1, and the one before that one, which is a sub n. So this number is based on 2. Ooh. That's hard to do backwards. There. It looks a lot nicer. I'll have to practice doing that backwards. So for this one, notice you're told two terms at the beginning, a sub 1, a sub 2. So to find the next term, which is a sub 3, you would take a sub the term before it, which is a sub 2, plus double the term before that. So this formula is basically saying to find a term, take the term before it, plus double the term before it. Before it. Yeah. So we would have 3, or sorry, a sub 2 is negative 3, plus 2 times a sub 1 is 4, which is 5. I'll do one more unless you do the last one. A sub 4, the term before a sub 4, a sub 3, plus the term before a sub 4. Before a sub 4. Before it. After before it. A sub 2, or sorry, 2 times a sub 2. So we would have a sub 3, we just found was 5, plus 2 times a sub 2 is negative 3. So we get negative 1. So see if you can find the next one. Hi, Brooke. How are you?
I'm good. How are you?
Good.
Good.
So you get 9. Now I want you to see if you could do the first one and the second one, and maybe the rest of them on the next one. Okay, the next part, we're going to write our own recursive formula based on a pattern of numbers. So here's the pattern 0, 2, 4, 6, 8, 10. Our first term, we'll start with a sub 1 rather than a sub 0. Equals 0. A sub 1 equals 0. So it's nice to start on the right foot. So you have to say where you're starting and how to get to the next step. So it's like a scavenger hunt. You need to know where you start, and you need to know how to get to the next step. If you just know where you start, and you don't know how to get to the next step, it's a really bad scavenger hunt. If you're given a map and you have no clue where to start on the map, you're in the mall, wondering, where am I? And you can't find the little X, you are here. It's really hard to use the map. So you need to figure out where to start, a sub 1 is 0, and how to get to the next term. The next term would be a sub n plus 1. And looking at the sequence, it looks like they're changing by 2. adding 2 every time. So the next term would be the term before it plus 2. And this works because, let's say the third term would be the second term plus 2. The third term is 4 equals the second term, which is 2 plus 2. And it works. Write the recursive formula for the next one. Let's pause and think about this. So look at how the numbers differ. We have a difference of 3. We have a difference of 9. We have a difference of 27. Something mysterious going on here. We have a difference of 81. These are cubes. Cubes. So if you start, your first term is 1. To get the next term, you would take the 1 before it plus a cube, like either 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. Cubes, perfect cubes. So you'd have the term before it plus 3, but it's not always 3. It's 3 with the exponent. In this case, it would be an exponent of 1, or you could say exponent of n. So for instance, let's say the third term would be the second term plus 3 to the 2. So the third term is 13, and that would equal the term before it plus 9. So it's 4 plus 9, so 13. It's 4 plus 9. So this formula works. And there are other ways that you could do this. The last one, I'll get you started and then let you try to figure out the relationship between the numbers. On one like this, you'd want to start with the first 2 terms defined. So you're looking, how do the first 2 terms relate to the next term? And then et cetera after that. So see if you could write a recursive function for that. So the answer for this is given right here. And you can find the second part of this video under 11.6, part 2.